Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Brian Woods, Vice President of EM Solutions at Altair. Welcome, Brian.
Thanks, Pat.
So Altair provides a broad range of software solutions in many application areas. When it comes to Altair's electromagnetic tools, can you tell us a little bit more about that area?
Okay. Well, as you say, Altair has really established itself over many years as a leader and innovator in many engineering disciplines, and has a lot of products both developed in-house and also acquired. And Altair's vision really is to help customers drive their decisions by leveraging simulation and high-performance computing and artificial intelligence. And when it comes to electromagnetics, over the past maybe 8 or so years, Altair has built up a really strong portfolio of solutions, mostly by acquisition, but also by then developing those solutions further. And the reason that we've really focused on that is that we know that electromagnetics and electronics as a broader area is something that is really important for the future. So if we look at what Altair really offers on the lowest frequency side there for things like motors and actuators and electromechanical systems, where it's more low frequency and transient and quasi-static kind of EM analysis, Altair has a tool called Flux, which is really capable there. Then in more general EM higher frequency application, we have the FEKO tool, which is looking at things like antenna design and filter design and RCS analysis, and EMC, as well as radiation hazard, all the general EM applications. And also with FEKO, we have dedicated tools for things like propagation modeling and network planning and spectrum management through acquisitions of WinProp and RAP, which in a modern world are really important factors to consider for EM. So we really cover from the lowest frequency all the way through to spectrum management side.
Yeah, a complete platform that you have there. So what are some of the biggest challenges you have in EM simulation?
So I think the challenges that simulation tools face is always linked inseparably from the same challenges that design engineers face. So, engineers are permanently faced with new problems that they have to solve. And I think particularly now, those problems don't fit anymore into the traditional engineering disciplines. So really, I guess the biggest challenge that we face is in being able to deliver fast, realistic, but most important, multidisciplinary or multi-physics simulation capabilities, where EM is an important part of that. But to solve the problems that engineers face, we need to be able to integrate different physics together so that we can, digital twins and things like that is really, I guess, the buzzword that people are wanting. And I think these bring a whole host of challenges to the EM solver problem or simulation problem. It's not so much about how good is your solver anymore. It's more important about how accessible and how integrated is your solver into different workflows. And then there's also things like, new manufacturing techniques, new materials, massive growth in computing power, and topics that have moved from academic world to more mainstream, like AI, artificial intelligence, and machine learning, and things like that, that mean that our users expect us to be able to consider all of these new things that weren't possible in the past. And there's also an expectation, as I say, with artificial intelligence and machine learning and things that we must be able to solve things faster and more realistic and be able to provide good solutions for all of these applications. I think historically in EM simulation, you could be a specialist in one area. But I think at the moment, nowadays, you move to a point where you need to be able to provide good solutions for pretty much everything. Yeah.
You recently released the 2022 version of Altair FEKO. Can you share some of the new things to look out for in that release?
Sure. Well, there's always a lot of things happening, but I can highlight a few of them. And this time I'm going to start the other way around. Let's start with sort of on the network planning and spectrum management side of things. Where we're looking at applications that are sort of over very large geographical regions using the RAP tool. And one of the things that RAP has is a really powerful, we call it the cost and coverage optimizer, that allows you to optimize the placement of space stations across a geographical region, both in terms of the cost and in terms of the coverage. And you can imagine this can be a pretty long running process. So what we've introduced with 2022 is the capability to be able to, during the optimization, what we call a soft break, to allow you just to pause that optimization process and analyze the best case so far, so that the network planner can decide whether he's got far enough, and give the optimizer some guidance. Then also, a lot of the underlying propagation models that are used in the propagation tools, they're continuously being improved, but particularly for the 2022 release, we've extended the one model, Longley-Rice propagation model, to account for terrain profiles. And then another interesting extension is that co-location interference analysis tools in RAP have been extended so that one can use touchstone files from measurements or from other simulations to configure the analysis, which makes things a lot simpler. And in future, one should look out in RAP for, a considerably better workflow and visualization tools for co-location analysis, hopefully during the year. Then if we move on to propagation modeling, which is more when we're looking at indoor propagation, inside a building, or urban propagation scenarios using the WinProp tool, we've put a lot of effort into 5G kind of applications, both extending our capabilities for beam steered antennas, which are typically in 5G, but also we've been working closely with our customers to identify even small capability features that have been missing, etc., that they need for 5G applications. These are often pretty small things, like being able to view the radiation pattern of an antenna along with the coverage analysis so that you can really interpret the results easily. Another thing that we focused on in propagation analysis is automotive radar, looking at time variant scenarios for virtual drive and virtual flight testing, which is very topical at the moment. And we've added various capabilities like FMCW radar post-processing, but also being able to consider more and more effects like the Doppler shift due to rotating objects in the analysis. And maybe while we're talking about propagation modeling, in 2021, last year, we introduced a new kind of solver, shooting bouncing ray solver. And in the 2022 release, we have made this more accurate by using quite a unique hybrid ray tracing approach that can be used to get both accurate and fast results for scenarios such as, for example, vehicles driving through tunnels where you've got a closed tunnel, etc. So there's a lot of stuff to mention, but let's quickly, so I'll just run through the highlights also more on the general EM side of things. We're continuously investing in improving our performance of our solvers. And particularly in 2022, our focus was on being able to use highly distributed HPC resources. So here we're talking about 1,000 CPUs or 2,000 CPUs distributed over many nodes. And this is something that it's a little bit of an ongoing project, but already with the 2022 release, we've made massive steps forward. For example, a typical large simulation across 128 cores, the example that I have in front of me here, runs 40% faster with 15% less memory and considerably more stable convergence, allowing us to deal with much bigger problems much quicker. Then we've also, in 2021, introduced a faster UTD solver. And in the 2022 release, what we've done is a faster UTD is just a solver that allows us to solve antenna placement type problems, but at arbitrarily high frequencies. As you push up the frequency, the simulation resources stay the same, the requirements stay the same. And we've extended that solver so that it can be used in conjunction with our other techniques, the method of moments and receiving antennas particularly. And this makes it possible to solve antenna coupling problems with that solver as well. And this is also something that we continuously plan to improve. Then two other things I'll quickly mention is we had an acquisition of a technology from a company called Ufacent a couple of years ago. And they have a method, which is a characteristic basis function method, that was typically used in radar cross-section calculations. And in the 2022 release, we've now made it possible to use that same method for non-RCS calculations, and look out for a tighter integration of that method into. And the last thing I just want to mention is that we hoped in 2022 to release a new preprocessor CAD interface. Unfortunately, we didn't make the initial release, but during this year, we are going to release that application, and that will become our new standard preprocessor from probably 2023 onwards. And what's really exciting about that is it's a great platform for us to be able to integrate our technologies much closer with a lot of other Altair tools and bring more workflows to the user in a much faster way.
Great, something to look forward to. What are some of the main focus areas for FEKO that you believe are going to help Altair users innovate in the future?
Well, I guess this brings us back to Altair's vision of helping its customers drive decisions by leveraging simulation and HPC and artificial intelligence. And I think obviously we'll continue to improve and expand our simulation capabilities, maybe particularly focusing on some of our less mature solvers that are well suited to some of the applications that we like electronics and EMC applications where we know a lot of the future lies. But I think the answer to the question about innovation and what will really impact on that is more about our seamless integration into Altair's multi-physics workflows and interfaces, so that designers can address some of the challenges that I mentioned earlier. I think that Altair's approach to integrating different engineering disciplines and the application of things like artificial intelligence and so to engineering problems is evolving very, very fast. And this really is going to be a game changer in terms of enabling our users to innovate in future. And what we want to do is really make sure that electromagnetics is part of the mix.
Well, thanks, Brian, for talking with me today about Altair and your 2022 version of Altair FEKO. To our audience, you can find more informational interviews at videos.microwavejournal.com. Thanks for watching.